Welcome back, students. So, in the previous section, we studied about how the EMF is getting induced when the rod is going to move in a uniform magnetic field. That is nothing but the change in the area. Because of the change in the area, the flux induced in it is changed and the EMF is induced in it. So, in here, we are going to study about the AC generator today in this session. So, in the AC generator, again the EMF is going to get induced, and of course we know the generator is nothing but a colloquial language. We would have heard about this word plenty of times in our day-to-day life, where the generator is capable of producing an electric current which could even operate few electrical appliances in your home. Sometimes the generators are even capable of operating even the heavy machineries. So listen, the AC generator, it completely works on the principle of electromagnetic induction. So here, if the angle changes, that in turn will produce the magnetic current. That in turn will produce the magnetic current. Why do I call it a magnetic current? Is the current produced due to the change in the magnetic flux. So the change in the angle. This is called the periodic EMF. This is called the periodic EMF. Where the very first thing that we saw was the self-induction, which in turn produced you a static EMF. Then we studied about the dynamic EMF, and now we are going to study about the periodic EMF. So now listen, how to produce a periodic EMF? Very simple and very straightforward. I take a coil that looks something like this, and I keep this coil in an uniform magnetic field. I keep this coil in an uniform magnetic field, and if the angle of this coil is going to change, because the whole thing is going to rotate, with some particular axis. The whole thing is going to rotate in some particular axis. So every time it rotates, the magnetic field that is going to link with this coil is going to change. So as the magnetic field linked with this coil changes, the flux gets induced. So why did the magnetic field change in the first place? Because of its orientation. So that is the reason why I introduced theta in here. So here we are going to study about few different things, how it is going to work. E is equal to d phi by dt, we know it, where phi is equal to b into a into cos theta, where theta is the angle that I have introduced here, where theta can also be rewritten as omega t. Now I will be resubstituting the whole thing into that, where E is equal to d by dt of cos omega t. And if I differentiate the whole thing, what happens? Differentiation of cos is minus sign, but we already have a negative sign in here due to the Lenz's law. That negative sign will be taken over by this negative sign. So what you will be getting is b into a omega sin omega t. B into a omega sin omega t. If we are going to introduce n terms in that, NBA omega sin omega t. So the whole thing can be rewritten as E naught, which is nothing but the peak value of the EMF. We already know this when we are studying the simple harmonic motion in our class 11. I could recall that this is nothing but the peak value of the EMF that is going to get produced. So if I ask you to find the peak value of current that could be produced. It is given as I naught is equal to E naught by R. So, I will plug everything inside, where the peak value of current that could be produced is given as N B A omega by R. So, this is the peak value of the current that could be produced using a generator. That is the peak value of the current that could be produced using a generator, where B stands for the magnetic field and omega stands for the angular frequency and R stands for the resistance of the coil. Okay. So, now the next question comes into my mind. Next question comes into my mind. When will my EMF be maximum? When will my EMF be maximum? You see, I will take this equation and I will answer you the question. E is equal to E naught into sin omega t. Sin omega t. So, this is nothing but a typical sine wave. This is nothing but a typical sine wave where omega t and E is here. Omega t and E is here. Look, this is the peak value of your EMFs. So, only if your omega t is pi by 2, only if your omega t is pi by 2, which means that only if the angle between your magnetic field and your plane is perpendicular, the EMF is maximum, which means consider my hand to be the coil, and only if your coil is like this, the area vector will point up. Okay, and if the magnetic field is moving from left to right or from right to left, that magnetic field vector will be perpendicular to your area. Only then your EMF will be maximum. Please make a note, very, very important. Only if your omega t is 90 degree, your EMF is maximum. If your omega t is 0 degree, your EMF is also 0, which means if your plane is like this and your magnetic field is going to hit it, the magnetic flux is maximum, no doubt in it. The magnetic flux is maximum, whereas your EMF is 0. Okay, that is very, very important. So, this is 0 and this is pi and this is 3 pi by 2 and this is 2 pi. Okay, well and good. But I usually believe in handling the whole thing in terms of time. So, time taken to complete one oscillation, let us take it to be capital T, and this is going to be T by 4 and this is T by 2 and this is T. T by 4, T by 2 and this is T. Okay. From this I can make many assertions. Listen, the first one, this is an alternating current. That is the reason why it is taking a positive and negative polarities in one cycle. First thing, being an AC current, it will reach positive and negative polarity. Positive and negative polarity will be reached in time t. Second, in first off cycle, in your first off cycle, your EMF will flow in one direction, and in your second off cycle, your EMF will flow in the other direction. So, reversing happens in every off cycle. Reversing happens in every off cycle. The reversing happens in every off cycle. Okay. And your EMF will be maximum at T by 4. The EMF will be maximum at T by 4. Very easy and very interesting this is. Okay, these are the various other factors that you should learn about the orientation changes. Okay. With this note, we are going to study about the application. Okay, we are going to study about the application. Application is one. We are going to apply that into an AC generator. See. So what is an AC generator, by the way? Very, very simple. Here we have a north pole. Here we have a south pole of a magnet. In between that I have an armature coil. And here I have two slip rings, and out of which I have a carbon bushes through which I will be drawing my current out. Okay, what is an armature coil, by the way? Armature coil is nothing but a flat plane of a metallic material on which you keep winding multiple coils like this. This is called an armature coil. The armature coil is actually placed between two polarities of your magnets so that you can produce a constant magnetic field in between these two poles, where these magnetic fields actually pass through the armature coil that is placed in between them. And if I try to rotate that, the magnetic field linked with the armature coil keeps changing with the time, as I have indicated in this particular graph, in this particular sine wave. The angle between the armature coil and your magnetic field keeps changing with the time as I rotate that. So according to this, the EMF gets induced in it. According to this, in the sense, what did I say? At time t equal to 0, your EMF is also 0. When you rotate it, and if your omega t is 90 degree, which means that your coil is actually flat like this and your field is going like this. Many people actually misunderstand this. If I say omega t is equal to 90 degree, everybody think the magnetic field is going to go into the plane like this. No. This omega t is nothing but the angle between B and A. Your A should be perpendicular to B. Your A will point up, your B will go like this. Your B and A are perpendicular. So your EMF will be maximum only when the angle between B and A is 90 degrees. So this is what it is. The same thing is applicable to the AC generators too. An armature coil is going to rotate and the armature coil will produce a maximum AC current when your armature coil is in the plane. Only when your armature coil is like this, it is not going to produce any EMF. Again it rotates, it produces EMF. Again it rotates, the EMF goes to 0, and again when it rotates, the EMF comes in. Like that, the EMF from 0 reaches the peak value, again it comes to 0 and it goes to the peak value on the opposite side. The same thing is happening in your AC generators too. These are called slip rings. These are called slip rings. What is the role of the slip rings, by the way? Slip rings are the materials which are actually going to produce an alternating current. If I am going to introduce some other material into that, I will be producing a DC current out of it. if we are going to produce, if I am planning to produce an AC current from this particular generator, I will only use the slip ring and carbon bushes into it. Okay. If I am going to use some other equipment, I will be producing a DC current. That's why I restrict myself to the AC generator. So this is a primary application of my orientation change, and which in turn produces an induced EMF. So this is how the things are going to work with the AC generator. So with this note, I think I will directly move into the transformers. I think this is a good time to start with the transformers, because transformer also work completely based on the phenomena of electromagnetic induction. See, the transformers are very important concept as far as the exam is concerned, because this is a real life application which we are using in our day-to-day life. So when I am talking about the transformers, there are actually two practical type of transformers, where in one type the transformer looks something like this. The transformer looks something like this, where here we have a winding and here we will have another winding. Okay, and at the center everything is left free. Okay, at the center everything is left free. Okay, this is one type of transformer. In the other type of transformer, both the coils will actually overlap each other. Both the coils will actually overlap each other like this. You see here. Okay, left side of this is called the primary coil. This is secondary. Okay, you see the primary and the secondary coils are actually kept aside, and here the primary and secondary coils will actually overlap. These are the two types. You can just ask me a question, sir, what is the primary difference between these two transformers? That is actually a practical one, where you give an alternating current on the left side, you give an alternating current to this coil on the left side, and due to the electromagnetic induction, and current get induced on your secondary coil, which will be taken out and it will be used for various other purposes. Here again the same thing happens. Here it is again mutual induction, and here it is again going to be a mutual induction, where the current comes in, it produces a varying magnetic field, which of course induces an EMF in the secondary coil, and those EMF is actually taken out and it is used for many other purposes. Okay. The advantage in using this coil rather than this is you can actually reduce few loss in the magnetic flux. Why? Here you have an air medium or any other medium that is filled inside between the primary and secondary coil, which in turn reduces the field strength, which in turn reduces your field strength due to a medium in between them. Here we don't have any other medium, so that here your flux loss is reduced. In the second type, the flux loss is actually reduced. In the first type, there is a possibility of the flux loss. Okay, fine. Now, as far as the exam is concerned, we will strictly stick only to the first case. Okay. There are going to be n turns in the primary side. There are going to be n turns in the primary side, and there are going to be n turns in the secondary side. Okay. What we are going to talk about is the ideal case. Ideal case. So if the transformer is ideal, the power loss is going to be the same. the power dissipation on both the sides is going to be same. The efficiency is 100%, but practically talking, you cannot produce an efficiency of 100%, it will just be 95%. So, Vs into Is is equal to Vp into Ip. So, if I try to rewrite this, Vs by Vp is equal to Ip by Is. Vs by Vp is equal to Ip by Is, which is equal to Ns by Np. So, this is the formula that we will use whenever we come across a ideal transformer. Okay, you see, potential and the current are inversely related, where the potential and the number of turns are directly related. You can ask me a question, sir, what is the primary purpose of using a transformer? And what is the primary advantage in using the AC current? You see, these things could operate only in the AC currents, this transformer. The primary purpose of a transformer is very simple, because in our home actually electric power comes very far away, comes from very far away. Okay, we don't have any power generating stations around our home. We have only few power generating stations for the entire country. So, you have to transmit the power from very long distance to different areas. If it is going to be a DC current, it is very hard for you to transfer the power for a long distances. So, that is one primary advantage in using the AC current. It is easy for us to transfer the current from any part of the country to anywhere, one thing. Second, how do I do that? Using a transformer. How do I use a transformer to do that? There are two types of transformer. One is the step up transformer and the other one is step down transformer. So, what is the purpose of the step up transformer? You see, step up transformers are actually used in the power generating stations, where they will produce a power and send those powers into your transformer to step up. How do you step up the power? So, in the case of step up transformer, the number of turns in your secondary coil will be greater than the number of turns in the primary coil, so that the energy that you give or the power you give through the primary coil gets increased in your secondary coil and it gets transmitted to long distances. Why do I do that? Because if the current is going to be greater, there is going to be huge amount of power loss when you try to transmit the electricity. So that what I will eventually do is, I will increase the voltage and I will reduce the current by doing this. So, this step up transformers are generally used in power generating stations. So, what is the primary purpose of the step down transformer? Step down transformer, what it does is, you get a high voltage current from your power generating stations. These step down transformers, which are located around our residencies, will actually reduce the voltage, the high voltage that is coming from there. So, in order to construct a step down transformer, I might have to reduce the number of turns in the secondary coil and I have to increase the number of turns in the primary coil. So, now these transformers are capable of reducing the voltage, the high voltage that eventually get from the power generating stations. So, these are the primary usage of the transformers, and as far as the exam perspective is concerned, you will be solving many questions completely based on this. Sometimes they will be providing you with voltage and current, sometimes they will be providing you with the current and number of turns. So, accordingly you will take the equations and you will operate. So, this is how the whole thing is going to work with the transformer, and the transformer is one of the most important questions that you will find in this particular chapter. So, with this note, we completely come to the end of this particular chapter, and as far as the competitive exam is concerned, the whole chapter is very important and you will be getting very easy questions out of it. In the next section, I will be showing you how to solve the numerical problems completely based on this chapter. With this note, I will end this session. Thank you.